All right, Algebra 1, we got our module test tomorrow, so we're reviewing all the stuff like independent and dependent, talking about parent functions, all the linear and quadratic, absolute value, piecewise, all that stuff, talking about sequences, talking about function notation, talking about correlation coefficients and scatter plots. That's pretty much a majority of what we need to be able to do on our test. So let's kind of jump into it here. We want to identify the independent and dependent quantity. And so if you really think about the idea for grandfather giving all the cash he had in his pocket to buy raffle tickets, basically for every ticket he wants to buy, it's going to cost so much money, and the cost really depends on the number of tickets. So I would definitely say the independent would be the number of tickets, and the dependent would be the ultimate cost for those tickets. Number 2, we're talking about a hot air balloon, and we've got a graph here that basically says that it descended initially, then they slowed down and just stayed at the same height for a little bit, and then it continued to descend into the ground. So now we have a few questions to answer. Identify the independent and dependent quantities. So independent is the x-axis, that'd be time, and also we're talking about height, so that'd be the dependent. I did leave off the units. This one's in minutes. And this one's in feet, because it did ask about the units as well. Domain and range, I'm really analyzing how far left and right the graph goes. And I really see that there's graph from 0 minutes to 50 minutes. So that's what I have for the domain, including 0, including 50. And then on the range, you're thinking about the opposite idea. You're thinking about how far up and down the y's go. And that goes as low as 0 and as high as the initial value of 2250. That's the unit that's in between 2000 and 2500. This value right here is 2250. So I see the graph starts there and it makes its way all the way down to when it's 0. Okay. So let's keep moving there. If I was asking about the maximum point, that initial point on the top left is 0, 2250. And initially, the hot air balloon is 2,250 feet above ground, so that would be what it represents in the context of the hot air balloon. Is it increasing, decreasing, both, constant? Well, it's actually a little bit of decreasing. It's decreasing here and here. But then it's also constant in the middle. So what I said was, hey, it is decreasing. It decreases in 2 different places on the graph. And then it also is constant right in the very middle when the hot air balloon stops descending, but it's not going back up. It's just staying still for a minute before it keeps going back down. All right, so the first part says determine whether each relationship represents a function. This graph passes the vertical line test, and that's why I said yes, this is a function. There are no repeating x values. However, for the table, I see these x values -1 repeating. -1 gives you 10. It's also giving you 20. I do not want repeating x values if it's a function, so we're going to say no, not a function. Circle the function types that are both increasing and decreasing for the same function. So linear I marked through because it's either going only down or it's only going up. It's not both. Constant is a horizontal line. It's not increasing or decreasing. It's got a slope of 0, so that's not right. Quadratic is a good answer because it could decrease then increase for that U-shaped graph, or maybe it's going up and then back down. So that one was good. I like that answer. And right below it, similarly to a U, if it was an absolute value graph, it would also do a form of increasing then decreasing. So those are my favorite answers. I do not care for exponential, though, because it's either rapidly increasing only or it's rapidly decreasing only. It's not doing both. Scrolling down. Question 5 says, circle the function whose graph consists of only lines. So, of course, a linear function, that's only lines, either increasing or decreasing. Constant functions are lines. They're just horizontal, like I said a minute ago, slope is 0. And, of course, absolute value, you have lines that are forming that V. But again, exponential and quadratic, those would both be curves. So those would not have any type of lines in their graph. Sketch a graph that has the given characteristics. First of all, I want something that passes the vertical line test, so I don't want any repeating x values, so that's good. I wanted it to be exponential, meaning x is an exponent, and so I just chose something like 1/2 to the x power, so that it would be decreasing later. I want it to be going down over time, and I also want it to be continuous, not discrete. Discrete is when you have just a few points in the graph and they're not continuously connected between the two of them. And so that's what I did in my graph here. I did decide to make it a full curve, not just points. Which data set would be a linear model best fit? So what I did is I looked for the y values. And these tables are kind of messed up in a sense. I mean, usually x is first, then y, so you really got to watch out for this. The x's are steadily increasing by 1 for all of these, so I could just kind of study the output values. And so I saw that this one went down 10, then it went down 5, but then it turned around and went up 5, and then it went up 10. So that is definitely not linear. I mean, it's like it's going down and back up, way more quadratic in nature. So I didn't really care for that one. But the B looked better because it's consistently adding 10 over and over and over. That is definitely a linear idea. It's adding a constant rate of 10 over and over and over. And so these other ones, the problem is the same idea is that they're inconsistent. Maybe they add and subtract, and they add and subtract. Or maybe they add over and over, but the number is different. You're adding a little bit more over time, so that wouldn't necessarily be a good fit either. For number 10, I thought the best way to really think about that was to turn it into a table. So I took all of the x values and put them in the table for list 1 in the calculator. And then all the y values I put in list 2. So let me display that for just a moment. Stat, edit. I put all the values in. And notice that the 1s are repeating. So that could definitely make your model seem a little off in terms of the correlation coefficient. The correlation coefficient is a value that measures how accurate your calculator's equation will be in terms of predicting the future. So this is what I got. And I have basically rounded that in red here. And so I haven't answered the question yet because I haven't gotten that far. But we want to kind of think about which of these equations would best fit that. And of course, we're going to round a little bit. This value is the correlation coefficient right here. And that tells me two things. One, this scatter plot is moving in the down direction. 2, 0.8 is not the best you could have, but it's not really that bad either. So the points are going to fall fairly close to each other in terms of that line of best fit. You may have a few points that are off. For example, the fact that those 1s are repeating, even though the x increased. That's definitely throwing the equation off just a little bit, but I'll let you go ahead and answer that question. Linear regression, they want us to talk about this slope value. What does that slope represent? So I talked about in my class how slope is y minus y over x minus x. Maybe you learned that in a previous class, and we'll definitely work more and more with that over time. But if I look and see what x represents and what y represents, x represents the idea about hours. Y, it says where y represents the temperature in degrees. So when you're thinking about slope, if you can kind of think about the words in the formula, this is the temperature over time. And so because that value is negative, every hour that goes by, the temperature is decreasing 2.8 every time 1 hour goes by. And that's the idea of that rate of change being negative. So the very last page says the population of a city starts at 378,000. And basically every year it's decreasing by 32,000. So this is an arithmetic concept. Arithmetic is a form of a linear sequence. So it is subtracting over and over and over. So I started with my table saying in the first year it was 378,000. And then I just subtracted 23,000 to move forward. So thinking about the domain represents years, and this is just going to keep on moving further and further, greater than 1. So that's why I said all of my x values are the years, and they represent 1 or bigger. And then for the range, basically because it's going down, I thought, well, population can't be negative. So basically, it's all values between 0 and 378,000. That represents the potential population being where it started, and as it decreases, one day it'll be nothing. So I would definitely look over your recursive and explicit. I'll do the recursive first. Recursive I put over here. It's the idea that you are starting with a sub n, and this a sub n minus 1 basically means the previous term. If you knew the very last number in the sequence, you could then just subtract 23,000 from it, and you'd know the next number. This is really used a lot in computer art, like fractals. So we're not going to necessarily use that in a minute to predict after a decade. That would be better used for our explicit formula. So the explicit formula, you have your a sub 1 value, then the common difference multiplied by n minus 1. So I replaced the first number and the common difference in the equation. And now I'm basically plugging in after a decade would be 10 years. And so once I plug in 10, you end up getting 171,000 people. That is basically subtracting 23,000 9 times from 378,000. Number 7 says a test shows that after the first hour of receiving a medication, there's 100 milligrams of the medication that's still in your body, and as time goes by, half of that is still in your body. So basically, after in the first hour, it says after the first hour, there's still 100, but then the second hour, it's half of that, 50, and half of that, 25, then half, and so forth. And so if I'm describing the domain, that is the potential hours, and this is just going to start at 1 because that's where it started in the problem and move greater than that. And for the range, well, if you're halving 100, that means it's going to approach 0. But if you remember, as you divide something in 2, it never actually becomes nothing. So it'll never actually be 0. It just keeps getting smaller and smaller and smaller until it's just some speck of a dose in your body. Still something, though. So recursive, to do recursive, I said, okay, you need to find the nth term by finding the 1 in front of it, the previous term, and multiplying it by that r value that is 1/2. Now, if you want to use an explicit formula, I would say, well, we start with the first number, and then we just plug in the hour that we're looking for, and they want us to see after 12 hours, what would that be? And so that's what we get. Plug in 12, and you end up getting 0.0488, which as a fraction would be 25/512. Last one, I believe this is the last one. The last one is one where we are changing in the calculator the years to be 0, 1, 2, 3, 4, and that's because I want this to represent the initial year when it began. Okay? So I put this in the calculator, and I got this equation. Notice that I did round this to the nearest whole number. And so it also asks me to talk about what the slope and the y-intercept represent. This number is the rate of change, 390 people added to the population per year. And this number represents the y-intercept, or the initial population in the first year, which is 2003. Notice that those numbers are very close. These numbers are extremely close. And that is because the equation is awesome. 0.94 is a very strong positive equation, meaning it's very accurate for predicting. So that's what we're going to do at the very end. It says, let's predict for 2020. So I'm going to subtract 2020 from 2003, meaning there's 17 years between the beginning of the study and where I'm trying to predict. So let's replace the x value with 17, and then that gives me roughly 28,485 people. Good luck tomorrow. Study all your formulas, especially for sequences. That is always challenging for students. Good luck, and I'll see you tomorrow.